We were in section 2.2. In chapter 2, we're working with linear equations. Where we left off in section 2.2 is looking at some different examples of places where it might come into play. And if memory serves me correctly, the last thing I was talking about was that sailboat at Houston Woods. They were trying to get the mast underneath a high, an electric line, and you really don't want to be bumping electric lines with big aluminum poles, okay? Unless you want to make the 6 o'clock moves, okay? And they couldn't exactly climb up there and drop a string down to measure how far things were, so they did the measurement on the height using shadows. And it really does work. Okay. Another thing, not sure exactly where all you're headed. Okay. On page 112, trying to put down page numbers so you have some idea of where we are. Example number 16. It talks about mixing a solution. You're thinking, well, Chuck, that's dumb. I'm not going to mix solutions. I'm not going into pharmacy. I'm not in pharmacy either. But I'm mixing solutions on a regular basis. Things like medicines for animals, because we got critters. Fertilizer. Oh, yeah. Sprays for the critters to keep flies off of them. Herbicides. Are you ever going to need anything like that if you just have a regular old house in a subdivision? Well, you're going to have a dog or a cat? I might someday. Okay, so maybe some Logan. Nah, never, nowhere near that. Huh? Okay. Ever going to have anything out in the yard other than just dirt? Well, sure, Chuck. Thank you. Everybody have a chance to sign the sheet? Great. Plants need fertilizer, don't they? Yeah, if they don't get enough, what happens? They die. If you put too much on them, what happens? They die. Man, whatever you do to them. No, somewhere in between too little and too much is enough. And mixing up the fertilizers is important too, because are plants always cheap to buy? I don't know if you've ever priced or not. You can spend hundreds of dollars for a tree. Okay? So you don't want to get this nice nifty new tree and the nursery says be sure you fertilize it, and you fertilize that baby and it goes, oh, it dies. Okay? So mixing solutions is important along those lines. If you ever wind up with a kid someday, rest assured you're going to be dealing with medicines with their ear infections and this, that, and the other thing. Okay? And it gets a little touchy if you kill them. Okay? So there are a variety of directions that this could go. Exactly which one or ones, who knows? I mean, none of us know where you're going to be in 10 years. But the point is, how do you do these concentration problems? Okay? Let's say we have a 30% solution. In the book, they talk about hydrochloric acid. Odds are you're not going to have hydrochloric acid around the house, but you might have something or other else laying around the house. Fertilizer. And you measure it, and in the book example, comes up with 153 milliliters. Doesn't really matter how many milliliters. The problem will work with any other number of milliliters as well. Okay? So you might have a whole bottle of it. You might have half a cup of it. Whatever the case might be. Okay? And it's marked at 30%. And what you need to do is you need to get it to 13%. Oh, this is the fertilizer type idea. If we put 30% fertilizer on the house plant, it's going to turn yellow and die. Okay? You just throw it out in the backyard and call it fertilizer. How much water do you add to this solution to cut it back to 13%? How much water do you add? done this kind of stuff. Wrong pronoun. I've done this kind of stuff with the kids at times. My wife always gets real nervous about it. Well, this particular bottle has 500 milligrams per blah, blah, blah. The kids only need whatever. Remix it, and she's there. It's okay. They've almost made it. The one's 18, the other's 15. So they might live through this thing. Okay? How do you go about doing this? Well, first off, does it make sense that by adding water we can dilute this from 30 to 13? We're making it lesser, right? So that sounds reasonable from the start. Could we add water and get it up to 40%? No, that's not going to happen. Because it dilutes it, right? Water will make it thinner. It won't make it more concentrate. Okay? Okay, so how do we do this? Well, what we're going to do is, in the end, we're going to wind up with some volume of whatever this is. I'm going to call it the final amount. I don't know how much I'm going to have in the end. I just know I have to add some water to this, enough to make it 13%. Okay? Well, this 13%, or this final volume, is going to be the 153 milliliters that we have right now, plus, do we know how much water to add? So I'm going to call that X, because I really don't know how much to add. Okay? And I'm going to make a note out here that X is the amount of water. That's going to be added. This may sound a stupid question. Can everybody read cursive writing? There are some schools that have stopped teaching it. I just want to make sure that I'm not putting stuff up there and everybody, hey, what are you doing? I'll go back to printing if folks are saying, yeah, we didn't get that. Okay, so what are you going to do? Well, what we know is whatever this chemical is that's in the 30%, there's going to be the same amount of it in this other mixture as well, isn't there? It's kind of like if you have 3 teaspoons of sugar in this cup of water, and you pour in a whole bunch more water to make it a whole gallon's worth. How much sugar is in the gallon's worth of water? The 3 teaspoons, right? It's not gone away, and you haven't gotten any more of it. It's the same amount of stuff as was there originally. Okay, so we know that what we start out with is a 30%. Convert that back to a decimal. And 0.3, which is 30% as a decimal, times the 153 milliliters tells us how much of the stuff, the active ingredient, maybe sounds better, I'm calling it stuff, this tells us how much of the active ingredient is in the original mixture. Does that make sense to everybody? When we're done adding water, we're going to have the same amount of the active ingredient, aren't we? Does everybody buy that? So what's going to wind up happening is, after we add the water, it's going to be a 13% mixture. And how much volume are we going to have in this new pot of the solution? Or bottle, whatever you're mixing it in. Well, the amount that you're going to have, isn't it going to be the 153 you started with, plus whatever water you put in to dilute it? Does that make sense? So it's going to give us 153 plus X. Is that an equation that you could solve? That looks real doable, doesn't it? We can take the 0.3. So we can do the 0.3 times the 153, and that gives us 45.9 equals, we got the 0.13 times the 153. I'm on the right-hand side now. So the 0.13 times that gives us 19.89 plus 0.13x. So far, so good? Now we got to do is solve for x. I'm going to subtract the 19.89 from each side, which will give, I'm going to do that by calculator, 45.9 minus answer, looks like about 26.01 equals 0.13x. Divide by the 0.13x. Wow. Actually, it's 200.0769231. If I copy down all of the digits on the calculator, which brings us to a conversation that's often asked on quizzes, tests, and stuff like that. How far should we go as far as the decimal goes here? Should we really include all of those digits? No. Why not? Well, because we don't have to. Okay, well, why not? Think about it. You're in the kitchen, or you're out in the garage. Really? You can measure to that part of a milliliter? Yeah, you can't even measure to those amounts, can you? Could you go out in your garage or into your kitchen and find something that will measure to the 0.0769231 milliliters? I doubt it. I think you'd have troubles finding something that will go much less than a milliliter. So how much would I be inclined to say we add? 200 milliliters. Now be careful, because the question or the answers or the questions that you're asked could vary. One of the questions could be, how much water do you add? Well, how much do you add? Well, let's see, what does x represent? Ooh, I'm glad I wrote that down way up here at the top. What does x represent? The amount of water you add. Well, we got down here that x is 200 milliliters. That means we're going to add how much water? 200 milliliters. Another question you could be asked is, once you get this new mixture finished, how many milliliters of the mixture will you have? How much of the stuff you're going to have by the time you're done mixing it all up? That's right. How much did you start with? The 153. And how much did you dump in? 200. So how much are you going to have total then? 353 milliliters. Okay. Is that a lot? With 353 milliliters, may I borrow your cup a minute, Myron? I'm not going to make a name with it. Okay. With 353 milliliters, fill this? I didn't hear who said, no, I wasn't sure if Dan here was. Logan's kind of cringing. Uh-oh, what'd I get into? Okay, Logan's saying, I don't think I'll fill it. Anybody think it's more than this? Gosh, I don't know, Chuck. Is 353 milliliters more or less than a liter? Less. It's about a third of a liter, isn't it? Have you ever seen, oh wait a minute, have you ever seen a 2-liter bottle? Half of that is what? 1 liter. I know the questions are getting really hard here. Okay? So a liter is about this much and about that big around, isn't it? Now 353 milliliters is about a third of that, isn't it? 353 milliliters a whole lot? No. Would it fit in Myron's cup? Yeah, it would fit in his cup. So you were right. Way to go. You got brave and daring, took a chance, and it worked. Does it make sense how we got started here? Where we set the two amounts of the stuff we're interested in equal? Does it make sense why we can get away with that? It's the same amount of sugar, whether it's in a little bitty cup or the whole room filled with water. It's still the same amount of sugar, which is what that line with the yellow, that equation is saying. It's the same amount of sugar. No matter how much water you add with it, that sugar's still there. Okay. That's got 2.2 taken care of. Good deal. Let's go on to section 2.3. And section 2.3 is not about equations. It's about things called inequalities. Oh no, not those. I hate those. Where are we ever going to use an inequality in the real world? Can you ever think of any place where you've run across an inequality in the real world? Pre-cal. Yeah, here we are. We just ran across it right now. I mean in the real world, not in this classroom. Driving, okay, your high school class. Is that the real world, or was that more like this? Yeah, more like this. You're driving down I-75. You ever going to run across an inequality? That might be a trick question. Chuck's kind of one of those shifty sorts. Got to keep an eye on him. Ever been in an elevator and run across an inequality? Dude, you got to be kidding. What are you thinking? Actually, believe it or not, you do. I don't know about you. First off, I try to avoid elevators. I prefer steps. Can't see the mechanics of it. I'm always afraid that something's going to happen. Yeah, you just sign up for that one. When you step into an elevator, everybody always makes eye contact and talks with everybody, don't they? Yeah, right. Everybody picks their own little piece of the floor and they look at it. And that's when you check to see when was the last time I polished my shoes. Okay? I always look at the little certificate from the engineer who inspected that thing. When was the last time this thing was inspected is one question. And the other question I look at is, what is the maximum capacity of this elevator? If it says 400 pounds and I look around, I'm thinking, I'm seeing way more than 400 pounds here. I'm off that elevator, man. When it says 400 pounds is the maximum capacity, and Myron's thinking, I may think about sitting further back next class. I'm not going to put words in his mouth. Okay? If it says 400 pounds, does that mean that elevator has to have 400 pounds on it to work? What's that 400 pounds mean? That's right, it's the maximum. That elevator will work for less than or equal to 400 pounds. Oh, that's an inequality, isn't it? No, Chuck, no. Tell me it ain't so. It is. You go driving across a bridge. Okay, we live on this little country road. They replaced the bridge last year. The bridge, I hate to say it, was over 100 years old. It was looking over 100 years old. Had a sign hanging on, 3-ton limit. Yeah, well, the guy who owns a farm across the street and I both know that thing will do more than 3 tons. Because we both routinely were running more than 3 tons over that bridge. Praying all the time, but running it. What's that 3-ton limit mean about that bridge? Less than or equal to. So if I walk across the bridge, I'm okay because I'm not 3 tons. It doesn't mean I have to be 3 tons to walk across it, does it? It means anything less than or equal to 3 tons is good. Now, when they put up a sign like that, do you think that they put it at where the bridge is actually going to break? Or do you think they rate it lower than what it's actually capable of? They rate it lower. Why? Because of idiots like Chuck who will run 5 tons over the bridge that's labeled at 3 tons. They won't have to be pulling me out of the creek. Okay? So they leave some extra for error, a safety margin. When you get on that elevator, it says 4 tons. That thing will probably handle 1,000. Okay, so we're merging on to I-75. we get out there a ways. And you see signs that say minimum 40 miles an hour. Have you ever seen one of those on an expressway? What's that sign mean? You got to do 40 miles an hour? You can't go slower than 40, can you? Can you go faster than 40? Oh, so your speed limit has to be greater than or equal to 40 miles an hour. But then you go a little further and there's this other pesky sign that says speed limit 65, speed limit 70. Is that a greater than or less than? Well, let's do an experiment. It says speed limit 70 miles an hour. You go whirling past the state trooper at 95 miles an hour. You're all good, right? Hey, I was doing at least 70. What's that 70? Is that a greater than or less than deal? That's a less than, isn't it? Because if you're going greater than, you're in the danger zone. Maybe you ever see Top Gun? Okay. There are a lot of situations in the real world where it's less than equal to, greater than equal to. You probably never really thought about it before. You sign a lease and they say maximum 2 dogs or 2 pets permitted in the apartment. Does that mean you have to have pets? No, 0 is a fine answer. Okay. There's another limit, less than or equal to 2. Does that make sense? So there really are a lot of places you can run into these things. We could spend the rest of the day just talking about places. But now that maybe you're thinking, okay, there might be some place where maybe this might come into play, let's talk about how you go about solving these things. Okay? You may have seen and done inequalities. You may have never seen them. You may have solved them and forgot it because you figured, I'm never going to need this stuff again. Or prayed that you were never going to need it again. Hey, let's go back to IT. Do they ever have conditional statements where something's less than or greater than in them? Yeah. Oh, rats. This stuff's there too. Talking some of you out of IT, huh? Okay. Let's say I have something like this. Say I have something like 2x minus 3 is less than x plus 2 over a negative 3. What's your first move? Yes, sir. Okay, we can multiply both sides by a negative and a negative 3 even. Do you buy that? If we multiply this side by a negative 3, that means we have to multiply this side by a negative 3, and that'll allow these to cancel. And when you multiply or divide by a negative number, what else happens on an inequality? The sign flips, doesn't it? Any idea why? Well, because they said so. And because it kind of just sticks in my mind, the sign flips. What winds up happening is, if you have something like negative x is less than negative 4, what that means is the opposite of x has to be smaller than a negative 4, doesn't it? What value could you plug in there for x that would make that work? Does negative 1 work? Because you have the negative of negative 1. What's the negative of negative 1? Positive 1. Is it true that 1 is smaller than negative 4? That didn't work. How about positive 5? Will positive 5 work? We're just experimenting. If you plug in a positive 5, you get negative 5 is smaller than negative 4. So does positive 5 work? Yeah. So, okay, here's 0. 5 is okay. Does 6 work? Yeah. So 6 works. Does 0 work? Nope. Does 3 work? No. So what we're getting is, do you buy here that anything larger than 4 will work? You starting to see the pattern? Okay. So anything bigger than 4 will work. Will 4 itself work? No. Is -4 smaller than -4? It'd be equal to, wouldn't it? So if it was a less than equal, that would be fine, but it's not. It's strictly less than, so it doesn't work. So what we want are the numbers over here, like 5, 6, 7, 8, 9, 10, 11, 12. Those work. Okay. Well, let's keep tabs of things. From this initial equation, actually inequality, I'll write it down here, -x smaller than -4. By experimenting, we know that we need numbers that are bigger than 4. We need 5, 6, 7, 8, 9, 10, stuff like that. If I multiply this inequality by a negative, the x is going to become positive, the 4 is going to become positive. Now, be careful. Is it still going to be a less than that puts us in the neighborhood where our answers are? It doesn't, because the answers are 5, 6, 7, 8, 9. So x is no longer smaller than 4. It's what? Greater than 4. When you multiply by the negative, it puts you shopping in the other neighborhood. Does that make sense? Okay, I multiplied by a -1, so that gave me a positive x. Multiplied by a -1, which gave us a positive 4. Now, originally I just brought down the sign and said, okay, look at that number line. Does what we have down at the bottom match the number line as far as where we know the answers are? Are the answers smaller than 4? And if you take a look at the number line, well, gee, the answers aren't smaller than 4. Where do the answers live? 5, 6, 7, 8, 9, 10. They live at bigger than 4, don't they? So to keep this inequality telling us the truth, when we multiply both sides by the negative, you then have to do what to the inequality to keep things accurate? Flip it. Okay? So when you multiply by a negative, that's what's going on, to indicate that you got to flip the sign. So this really is going to wind up greater than. All right, let's go back to the left-hand side. Let's multiply everything through by the negative, and I want to be careful. So before I do anything else, I'm going to flip this inequality the other direction. Does that make sense why we're flipping the inequalities? Okay. I hate just saying flip it and move on. And people just say, well, I wonder why. I don't know. Chuck said so. Okay. Please? The y is what we just did over there in the red, because it changes the neighborhood that's going to work for the answer. Okay, that's what we were just doing over here in this section, where the pattern is when you multiply by a negative, you reverse the inequality. You turn it around the other way. Okay, so let's see what we have here. We're going to have a -6x plus 9 on the left-hand side. On the right-hand side, the -3's are going to cancel, leaving us with x plus 2. Interesting. What should we do next? There are 2 different moves you could make. Really more than 2, but... Yes, sir?
Add 6x to both sides.
Okay, let's add 6x to each side, which is going to give us 9 is greater than 7x plus 2. Now what? Yeah, let's eliminate the 2, subtract 2 from each side. So we have 7 is greater than 7x Next move, divide by 7. Now wait a minute, when I divide by 7, do I have to flip the inequality? No, that's only if I'm dividing by -7. Okay, so I'm going to get 1 is greater than x. Now, sometimes this is kind of confusing for people to read because you're used to seeing the variable on the left-hand side. So I can rewrite this. I'm going to do the x like that and the 1 there. And I leave the inequality like it is. You have to flip it around, don't you? If you're going to move it around, pay attention to what the inequality is pointing at. In the line above, see it? It's 1 is greater than x. It's pointing at the x, isn't it? So when you flip things around, make sure the inequality points in the direction of whatever it was pointing at before. This says x is less than 1. That means that that equation, that inequality will work if x has a value smaller than 1. So the solution would look like anything from -infinity all the way over to 1, but use a parenthesis to say you don't include 1. How many different answers are there to that problem? A lot. An infinite number of them. Yeah. Okay, let's take a look at another one. Let's go after, let's see here. Crud. Let's say we have something like this. The little box means that's the end of the problem. Let's say I have something like 1 minus x is greater than 1/2 x minus 2. 1 minus x is greater than 1/2 x minus 2. What would you do with this one? How would you work this? It's okay, there isn't a right answer and everything else is wrong. There are a number of different approaches. Yeah, combine like terms. Move x's to one side, move the constants to the other. Well, I'm not sure, Chuck, which side to move the x's to, and I don't want to make a mistake. You can't. Either side's fine. Yeah, add x to each side so you're not dealing with negatives on the x's. So is that okay to add x to both sides? Okay, so that's going to give us 1 is greater than, now you have a 1/2 plus 1. What's a 1/2 plus 1? 1 1/2, so that's 3/2. Subtract 2. Okay, so what's your next move? Add 2 to each side, so I'm going to get 3 is greater than 3 over 2 x. Now what? Okay, yeah, we can turn the 3 into 3 over 1. Or how about we multiply the right-hand side by 2/3? What would multiplying the right-hand side by 2/3 do for us? Bless you. It cancels out the 3/2, wouldn't it? Does that make sense? Well, if I multiply that side by 2/3, guess what else gets multiplied by 2/3? And we could put that 3 over 1, so we can see it as a fraction times a fraction. Okay, so let's see, what's the left side going to simplify to be? 2. Keep this pointing like that. The 2/3 and the 3/2 are going to cancel. So x is bigger than 2, right? We pick numbers like 3, 4, 5, 6. Okay. Be careful. I would encourage you to always get in the habit of rewriting this stuff like the x on the left side, the inequality point of whichever direction it's, or to whichever side of the equation. Keep it pointing, in this case, to the x. If it would have been pointing at the 2, we would have kept it pointing at the 2. And this gives us an answer where x is less than 2. So in this case, if you pick anything from negative infinity to 2, you're okay. Any number in there will work. Will the number 2 work? No, because that would make the two sides equal. Now, one of the things that you can do as well is, or another way to solve this, and let's just go with this, is at this stage right here, we have the 1 is greater than 3/2 x minus 2. If I move the 1 to the right-hand side, that's kind of weird. I'm going to get 0 is greater than 3/2 x minus 3. Once again, we can exchange the sides, and we'll do this 3/2 x minus 3. We're going to have a 0, and which direction does the inequality need to point this time? Keep it pointing to the 3/2 and all that stuff. Okay, so we've got that. So what? Another way to go about solving this is to take this and graph it. It's going to intersect the y-axis at -3. See it? The -3. What's the slope? 3/2. So it's going to come through kind of like that. And what we want to know is, where is that below 0? Where would that be below 0? How about this whole section like that? Is that below 0? And what you could do then is, if you have a graphing calculator, or go on Wolfram Alpha or something or other, find what that x value is there that equals 0, and it's 2. So where it intersects the x-axis is at 2. Okay, so we know something at 2 is happening. And do you see the side that's shaded green? Is that numbers bigger than x equals 2, or numbers that are smaller than x equals 2? Smaller, aren't they? So what that really means is that anything in that direction is going to be an answer. Isn't that what we came up with before? Works either way, doesn't it? Okay. Well, gosh, Chuck, which way do you want us to do it? Well, maybe on an upcoming quiz or test, I would ask you to solve it symbolically, which is like we did on the left, and then ask you to solve it using a graph. Well, solving it using a graph would mean you get to this, you graph it, and you figure out where it's below 0 or above 0, whichever you want. Does that make sense? So there's a couple ways of doing that. And if you're sitting there thinking, I'm not sure I got that, it's okay, we got a movie. Okay? Let's take a look at another example. Anybody here gonna go into business? Anybody gonna go into business? Got a couple folks shoot their hands right up. It's actually kind of a trick question. If you're working for a company, what are you doing? Aren't you part of a business? Geez, I guess just about everybody's going into business, aren't they? In some way or another. Okay? Okay. Stretching it a little bit like the inequalities out in the real world. Okay? But whether you're running the business, owning the business, or an employee in the business, do you need to be concerned about that business being successful? Yeah, because if it isn't, then what? you're going to get hungry. Okay? And it doesn't matter which one of those three you are. Good rebound. One of the important things or points in a business is something called a break-even point. Does anybody happen to know what the break-even point is? Kaylee, is it okay if we put you in business here? Okay, Kaylee starts her own business. Anything in particular you'd like to sell or make? Cakes. Ooh. Okay. So Kaylee goes into the cake business. Kaylee's Cakes. Right next to Cervati's. Go bring them to their knees. Cervati's is pretty good, aren't they? Yeah. So, anyway, now she isn't going to try and put Cervati's out of business. There's plenty of cake business for both of them. She goes into business, and the first week she opens the doors, does she make a big profit? The second week? The third week? The fourth month? The first year? Oh my gosh, and some of you are getting concerned for Kaylee. Oh no, what's poor Kaylee? How long does it take for an average small business to be able to stand up on its own? 5 to 7 years. It takes that long for the owners to figure out advertising, figure out how to reach their clientele, build up a clientele. The folks who come in every week or two for cupcakes, come in every year for birthday cakes. Okay? Come in. Do you sell pies too, Kaylee? Oh yeah, we sell pies. We're in good shape. Okay? Come in for pies. Pumpkin pie at Thanksgiving. Okay? Takes a while for that to build up, doesn't it? And while that's building up, Duke Energy isn't going to charge her for the electric, right? The folks whose building she's using aren't going to charge her any money for renting the property until they want their money every month, don't they? Typically, the first at least 5 years a business is trying to build itself. You lose money. That's a long time to be losing money. That means that Kaylee, for the first 5 years, is going to work there from, do you sell donuts? That means she's got to get there at 4 in the morning. Oh, maybe I don't sell donuts. Because if you're selling donuts, you open at what time? By 6 o'clock. The one in Oxford opens at 5 a.m. They're sold out by 10:30 each morning. You got to get there or forget it. So Kaylee's getting there at 3:30 or 4 every morning to get things mixed up, to let the batters rise, to get the donuts fried, the whole routine, so that at 5 a.m., in come the customers. Well, in comes the customer. Rats. Was hoping for more. She works till 6 or 7 in the evening, closes and goes home. How much money did she make that day? By the time she pays the electric, the insurance, the taxes, the rent, oh yeah, for the flour, the eggs, the sugar, the flavorings, everything else that goes in, Kaylee has less money than when she started that morning. In fact, she made so much that day that she doesn't have enough to buy herself food unless she borrows money from somebody. So she swings by moms and dads on the way home. And this goes on for 4 or 5 years. We're going to put you on the fast track. 4 years later, you've been working from 3:30 or 4 in the morning till 6 or 7 every day. Okay? And a magical day happens. Enough people come in the door one day and buy enough product that she can pay her bills. There's nothing left over for Kaylee to stop by McDonald's on the way home and get a cheeseburger for $1. She hasn't made $1, but all the bills are paid. This is a very happy day for Kaylee. This is the break-even day. And from there on, it just keeps growing and growing, and Kaylee becomes as big as Cervantes or bigger. And 20 years from now, people point at her and say, gosh, Kaylee sure is lucky. Was Kaylee lucky, or did she work herself hard and sacrifice a lot? Okay, so when you see those small businesses that have made it, they aren't lucky. Okay. But the break-even point, it's the first place you want to hit. That is where your income is equal to your bills. All right. Wanted to make sure that break-even point is more than just a quick definition, so wanted to give you a quick story. Example they give in the book, selling earbuds. Okay? The cost to make them is going to be 5 times however many pair of earbuds are made plus $200. Well, what's the plus $200? Bingo, you got it. That is fixed costs. Fixed costs are the bills that you have to pay even if you're closed. Why do I have to pay something if I'm closed? The electric, the water, the insurance, the rent, the advertising. They're still advertising, aren't they? All that stuff's going on even while you're in bed sleeping, trying to get ready for the next day. You're still paying all that. That's what that $200 is. The 5 is how much it costs to make a pair of these earbuds. So they cost $5 a pair to make. So your total cost is your variable cost, 5Q, the variable, the part that can change. Fixed, the part that you're stuck with. You can't call Duke and say, hey, will you cut my electric bill in half? I'll say, yeah, use half as much electric. Oh, yeah, why didn't I think of that? Okay. Okay, the other half of this deal is you sell them for $15 a pair. What's the revenue function going to look like? Revenue is the total money that comes in. If you sell 10 pair of earbuds, how much money comes in? $150. If you sell 20 pair of earbuds, how much money comes in? $300. You take the price you sell them for times how many pair did you sell, right? Everybody buy that? Now what you're really concerned about is your break-even point. That's where the profit equals what? 0. So the profit function is going to be, what's the equation for profit? Okay, cost and revenue, and it's going to be revenue minus the money that comes in minus the bills you got to pay. Okay, so it's going to be whatever money you made minus whatever costs you have. In this case, it's going to be the 15Q minus the 5Q plus 200. Now, I've intentionally made a mistake with that equation. What's the mistake? We've got revenue minus cost. Not really. Oh, yeah, it should be. Thank you. Jeez. Okay. Let me rephrase that. There were 2 mistakes, okay? So Logan caught one of them. When you subtract, don't you subtract the entire cost? That is a very common mistake to make, to just write down the minus. And the problem is, if you write it down as it was before, it's only minus the 5Q, isn't it? What we really want it is the 15Q minus 5Q minus 200. distributing that negative. Does that make sense to everybody? You okay? All right, let's call it quits here. I don't want to run this thing too far. We'll finish this up on Friday. Hey, Friday, there's a quiz, isn't there? It'll be over some of the stuff with inequalities and over some of the story problems and the other stuff in section 2.2 on solving equalities. Okay, equations, linear equations. Go get them. I'll see you on Friday.